Power plant, operating controls. Objectives. After completing this section, you will get familiar with power level, electric master and engine master, engine control unit voter, engine control unit test button, and alternate air. Power lever. The DA40NG is powered by a single engine, that is controlled by one power lever. This lever controls the performance of the engine, and is located on the center console between the two seats. The concept of front and rear position of the power lever is defined with regard to the flight direction. The power lever in DA40NG airplane has two throttle markings expressed in percent. The 0% indicates no power or idle, and 100% indicates full power or max. The position of the throttle determines the desired engine power. The maximum forward position corresponds to full power. The maximum rearward position corresponds to idle power. The power lever has two electrical plugs that are connected to separate and independent electrical systems. The electrical cables connect the power lever to the engine control system. One cable provides signals to the engine control unit A, while the other supplies the engine control unit B. Both ECS are contained in one box, located under the pilot's seat in the cockpit. The ECU connects the power lever and other airplane systems to the engine. As the power level is set to the desired position, the ECU controls the manifold pressure, injected fuel quantity, and the propeller speed. These controls are necessary to achieve the preselected engine power. The power lever is connected to the Hall sensors by means of a push rod. The power lever uses electrical sensors, which principle of operation is based on the Hall effect, to supply the ECU with signals in proportion to the position of the power lever. The engine control system uses these signals to set the power output, and to control the propeller governor, to achieve the best RPM for the power setting. The engine has an electronic engine control unit, also known as ECU, controls the propeller pitch angle hydraulically via the propeller governor. The propeller governor is flanged onto the front of the engine behind the propellers. It adjusts the propeller pitch automatically via an electromechanical actuator, to achieve the required RPM of the airplane. In a normal flight condition, the propeller governor maintains the engine speed set by the power lever. It also controls the maximum RPM of the engine. In the case of oil pressure loss in the propeller governor, the blades go to the low pitch, known as the fine pitch. This automatic adjustment produces maximum static RPM. Note: if the governor fails during a flight, it is possible for the propeller to overspeed. In this situation, the flight can continue according to Chapter 3.2.6, Defective RPM Regulating System. The ECU, also known as ECU, measures the engine performance and sets the governor to regulate the flow of the oil pressure to the propeller, in order to change the blade angle such that the required RPM is obtained. If the engine speed is too high, the governor opens the pilot valve, so the oil flows into the propeller hub, causing an increase in the propeller pitch, and reduction in the RPM. If the engine speed is too low, the governor releases oil flow out of the propeller hub. The piston moves aft, to reduce the blade angle, causing an increase in the engine RPM. Caution: following governor failure, the RPM should be adjusted using the power lever. Every effort should be made not to exceed 2,500 revolutions per minute. Caution: the power lever should be moved slowly, in order to avoid overspeeding and excessively rapid RPM changes. The light wooden propeller blades produce more rapid RPM changes than metal blades. Warning: The propeller blades may remain in the position of the highest pitch, in case of a malfunction of the ECU. In this case, the reduced engine performance should be taken into consideration. Electric master and engine master. The electric master and engine master are responsible for starting the engine of the airplane. The electric master is a key switch, located on the bottom of the instrument panel, next to the fuel transfer switch. The engine master is a switch, located on the left instrument panel, below the left ventilation nozzle. The electric master is operated by a key that can be rotated into 3 positions. When the key is in the off position, the battery power is disconnected. When the key is set to on position, the battery power is connected to the power distribution system. Positioning the key to start enables starting the engine. For the engine to start, the key must be turned clockwise, against the spring to the start position. The force applied to the key must be released when the engine starts, so the spring can return the key from the start position to the on position. For the engine to start, the engine master switch must be set to on. The engine starter cannot operate without the engine master switch set to on, even if the electric master key switch set to start. For the engine to shut down, the engine master switch is set to off. The starter system has a high-powered electric starter that operates through a circuit of DC power supply. The current starts flowing from the electric master to the engine master, then to the starter relay. A start circuit breaker located in the main bus is also connected to starter relay. Finally, the starter relay provides the starter in the engine compartment with the power needed to start the engine. When the engine is started, the electric master supplies the battery in the engine compartment. Engine control unit voter. The ECU voter switch is an instrument used to control the operation of the engine, which enables selecting between 2 ECUs. The ECU voter is located on the left side of the instrument panel in the engine section and can be toggled between 3 positions, ECU A, Auto, and ECU B. The engine can be controlled either by ECU A or ECU B. However, for all normal operations, the ECU voter switch is set to auto for the automatic selection of appropriate ECU control. If the active ECU fails, the ECU voter switches automatically to the other ECU, giving it the authority to control the engine. The failed ECU is indicated in the annunciation window and presented as ECU A fail, or ECU B fail. If this automatic switchover fails to comply, the switchover between the ECUs can be moved manually by the pilot. This procedure must only be considered in an emergency. Engine control unit test button. The ECU test is a button located on the left side of the instrument panel, between the ECU voter and the engine master switches. The ECU test button activates the test sequence of the system. The ECU test is possible only on the ground, and with the power lever set to idle, 0%. If the ECU voter switch is not in the auto position, the ECU test will not start. The self-test of the ECU starts by pushing and holding the ECU test button throughout the whole procedure. The ECU switches from ECU A to ECU B, or from ECU B to ECU A, whichever is active at the moment. The ECU keeps monitoring the propeller RPM automatically throughout the process. Finally, the ECU performs a switchover to the initial active ECU. The test is completed by releasing the test button when all caution lights and messages are turned off and the engine performance is in the normal RPM range. Note: during the ECU self-test, caution, ECU A fail, and ECU B fail, are extinguished during the whole procedure. Caution. A slight shake of the engine may occur when switching from one ECU to the other. Caution, ECU test failure. If the ECU A and/or ECU B fail indicators do not illuminate during the test sequence, there is a malfunction in the engine control system. Terminate flight preparation. The ECU test procedure must be completed without any error. ECU A and/or ECU B fail extinguished after test completion. In case the test procedure aborts with an error indication, ECU A fail, ECU B fail, or both indicators remain on, terminate flight preparation, even if the engine seems to run smoothly after the test procedure. Caution, parking brake during the ECU test. During the test sequence the engine will produce thrust. Therefore the parking brake must be set. Note, aborting of the ECU test. The engine oil and/or the gearbox temperature must be in the green range before starting the test sequence. Efficient engine warm-up may require higher power settings, maximum of 50% engine power. Releasing the ECU test button or manipulating the power lever before the test sequence is completed will abort the test sequence. Caution, engine temperature. Running the engine with the voter switch on ECU A or ECU B, other than for the ECU test or in case of emergency, is prohibited. The engine control system redundancy is only given with the voter switch set to auto. Alternate air. The air intake has three main parts: the alternate air valve, air filter box, and air filter. These parts are responsible for making up the low-pressure, engine air intake system, of the DA-40NG airplane. A lever located on the left side of the center console under the instrument panel operates the alternate air valve. The alternate air valve and the air filter are both attached to the air filter box. The air filter box has two inlets. One inlet is connected to the air intake duct via a flexible hose, while the other inlet has a direct air intake from the turbocharger in the engine compartment, to the alternate air valve passing through an air hose. The alternate air lever is connected to the alternate air valve using a Bowden cable to allow air supply from the engine compartment once the lever is activated. In the event of power loss due to icing or blockage of the air filter, an alternate air operating lever is used to activate the air supply from the engine compartment. In a normal operation, the alternate air control lever is set to off position, that is represented by alternate air placard on the lever. To open the alternate air source, the lever must be pulled to the rear. Alternate air on placard is visible on the lever when the lever is in the rearward position. Summary. With this section, you got familiar with power level, electric master and engine master, engine control unit voter, engine control unit test button, and alternate air.